Hello there, I'm Thomas Hatsios, German-American pilot flying the Boeing 787-900 tonight flight from Zurich International Airport. We're gonna be able to fly in Zurich, Switzerland, Germany. They can come back to the Zurich International Airport, runway 14 for an Ilsloc localized landing. So now I'm in the cockpit for the pre-takeoff preparation of the quality wings. Microsoft Flight Simulator Boeing 787-900. I'm gonna start showing you the cockpit instruments, the displays, and the functions of the Boeing 787-900 jet aircraft. I'm going to start with the primary flight display that displays the airspeed indicator, the airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the barometric pressure within the atmosphere, the target selected from the autopilot flight director system panel, also the radio altitude above the ground level. We have the altitude indicator with the artificial horizon, the pitch ladder in degrees, and the bank angle in degrees. Also, we have the vertical rate of climb and descent of the aircraft in 10,000 feet per minute, or the stiffness of the trigonometric angles in degrees can climb and descend. We have also the horizontal localizer and vertical glide slope of the Lszh localizer system. The instrument landing system that receives frequency from the radio guidance, the instrument landing system of the airport transmits radio frequency through the antennas. We have also the Lszh localizer crossbars, the flight director crossbars, and the autopilot crossbars for automatic guidance of the aircraft, the flight director crossbars for manual guidance of the aircraft, the angle of attack of the aircraft as it flies, and the flight mode annunciator with the autopilot and the auto throttle later and vertical navigation modes. So we have also the HSI, the horizontal situation indicator with the integrated display of the flight plan. We have the standby flight plan. The navigation display, that displays the GPS, the inertial reference position of the aircraft, the terrain weather reflections from the weather radar. You can see the terrain map with the airports named, the runways we're gonna use for takeoff and for landing. So we're gonna use the runway 14 in the Zurich International Airport, where we are located right now, the Lszh, for takeoff and for landing both, and we can align with the magnetic north pole heading of 136 degrees for this reason. So you're gonna see also that. So you're gonna see also we have the magnetic heading and track, the magnetic north pole and true north pole, and magnetic variation depending on where we are in the world. You can see the terrain colors with green, yellow, and red. Over here we have also the flight plan we created over here. So we have you can see here, I'm gonna show you this way. Over here you can see the flight plan from takeoff, climb, cruise, descent, approach, and landing. Over here the waypoints we have to transverse through, then descent and approach and landing. You can see also the runway symbol over here. You can see the vertical glide, climb here, and then the descent, the altitude we have to reach, and we can set all the values of the airspeed, heading, over here airspeed, heading and altitude selected from the autopilot flight director system panel, the FDS panel with the autopilot and the auto throttle and the flight director switches. So you're gonna see also that how we're gonna use it. So I'm gonna show you the navigation display. We have also the NDPs, the workstations, the ADFs. We have the navigation aids, the waypoints, which are horizontal and vertical navigation fixes. The aircraft will have to traverse through its flight. If we select them using the flight management computer, I already used the flight management computer to create a flight plan here. As you can see, this flight management computer, I input all the data of the flight, so this includes those over here. The flaps, the takeoff speeds V1, V-rotate, V2, center of gravity and trim for this fuel 99. So we need to decrease also the fuel here. Fuel and payload, so change the fuel and the payload. I'm gonna decrease it. So here we use this to change the fuel, and then change also the payload, decrease it. For this flight we don't need to be so heavy, so we're gonna have a different center of gravity now in fuel. So we use all the inputs here from the flight management computer for the flight. The route, initialize, index, performance. So we have 0 fuel weight, fuel, flight. So the takeoff over here is gonna be the same. The route, origin, destination, the runway we're gonna use, Zurich International Airport, departures over here, departures with the standard instrument departures, and arrivals with the stars, the standard terminal arrival, waypoints and fixes, and the legs from takeoff, climb, cruise over here, so we keep climbing 6,000 feet, heading of climb, next page, then cruise over here, Nitra and Mativ, then start the descent back to the level over here, 7,000 and 6,000 feet, and then we have the runway. We have to arrive here, runway 14. So we have a complete flight plan or flight path or route. We can see this is displayed here with this purple line, and here also with the waypoints we have to cross through as we flying. So we're gonna have all this data in the navigation display. We have also the terrain and weather reflection from the weather radar. We can see with the color red, green and yellow the elevation of the terrain around you. We have also the display of other aircraft that fly around us using the transponder, the DSP and ADC transmitter receiver that transmits our frequency to other aircraft, and the air traffic controller receives from other aircraft and displays the diamond shape using the TICA system, the traffic collision advisory system. We have an incoming collision. It's gonna give us a warning. So we have, it can calculate the distance of the other aircraft, the altitude difference from our aircraft, whether they climb or descend, and the velocity closing in, how fast our aircraft and the other aircraft are coming closer or away from each other. So we have also As I told you, the flight plan, I created the flight plan using the flight management computer. I input all the data, the takeoff gross weight of the aircraft includes the empty weight plus the passenger plus the fuel on board, where the fuel is stored in the left and the right wing and in the center tank. This calculates the center of gravity using the minor dynamic chord position of the forward wings, usually is 23% of the Mach, with a horizontal trim stabilizer of 4.25 degrees. So we have also here system the fuel. Maybe we have more fuel here. We have should be having less fuel. So we need to change the fuel one more time. Well, this makes big change. 1% is 4,000 pounds of fuel. So now we have the correct center of gravity now that I use in every flight almost. It's gonna be different. So change the fuel again. 34 point something. 34.6 I think. It's gonna be the same values. So we use this, the center of gravity is calculated using the flight management computer. It will give us using the runway we're gonna use for takeoff, runway 14 in the Zurich International Airport, the runway length, the runway slope, the wind direction and speed, the barometric pressure, the altitude, and also we use the flaps for takeoff 15 degrees. It calculates using the center of gravity the mean aerodynamic chord position of the forward wings, about 23% of the Mach or 18% for this flight. So we're gonna have the horizontal tail stabilizer also trimmed from takeoff, climb, cruise, descent, approach and landing during the whole flight, either automatically using the auto trim system or manually using the manual input of the control wheel here. So I'm gonna show you either way to trim the horizontal tail of the aircraft. I will explain about aeronautical and aerospace engineering before showing you the flight controls. So also as the aircraft flies and burns fuel, it calculates again the center of gravity automatically using the flight management computer. It takes up all calculations. So you can see here the aircraft wings hold the aircraft weight as the aircraft flies. The mean aerodynamic chord position is about 23 or 18% of the Mach of the mean aerodynamic chord position using the fuel calculations, which affects also these things. We have the longitudinal axis, which affects the horizontal tail position, the stabilizer. So we can trim the stabilizer up and down during flight to balance the aircraft this way by moving up and down the stabilizer trim. We can use also the elevator for climb and descent. Also we have the rudder, the vertical tail also. So you will see other how it affects either flight control. We have also so we have the lateral axis from wingtip to wingtip and the vertical axis through the center of gravity. This is also the position where the stall will begin as the aircraft flies. For a given angle of attack and airspeed, the airflow of the air mass will become detached from the top surface of the wing. So we need to avoid the stall during the flight. We have also the wings. You can see the bottom surface is more flat, so the airflow is moving slower as the aircraft flies, so there is higher air pressure, which pressurizes the aircraft weight up into the air as we fly. Also you can see we have the top surface of the wings. The airflow is moving much faster above the wings, So there is a lower pressure above the wings, which sucks the aircraft up into the air, and we can fly. So this is the Newton's physics Bernoulli theory of fluids and aeronautical and aerospace engineering you need to know for flying the aircraft, for the air transport pilots, the pilot license also. So I'm gonna show you now perhaps the flight controls, then autopilot flight director system panel, then make an engine start before doing the flight from takeoff, climb, cruises, and approach and landing. So I'm gonna start showing you the flight controls of the aircraft right now, how to use using the size of the Lszh Extreme 3D, which controls the function of the yoke of the vertical yoke, the column, for controlling the elevator of the aircraft for climb, descent, and flight. Also the elevator, also the ailerons and the spoilers for bound goes left and bound goes right. Using the control wheel, also we have the rudder pedals for the vertical tail, the rudder, for making yawing turns, for the nose wheel steering the ground, which is interconnected with the tiller also until some airspeed like 70 knots. And also we have the toe brakes of the rudder pedals. We have the thrust from the engine's thrust levers, the flaps levers, the flapping slot, external retractor, the speed brakes, and the trim of the horizontal tail. Also the trim function, the alternate trim, and the trim cutoff switch for the auto trim function. So you can disconnect the auto trim function. So I'll start maybe showing you this control switch over here. The trim switch for you can trim up and trim down like this. All the time you will see the trim position here in the display. You will see the stabilizer trim up and down, and also you can use the rudder trim. So this trims the horizontal tail up and down during flight, during normal flight, manually. You can use also the auto trim function from the autopilot flight director, auto throttle, and flight management computer. We have also the alternate trim, alternate pitch trim here for horizontal tail. You can see the parking brakes also here up and down. So I told you we have the auto trim function over here from the autopilot flight director system panel. We have a failure of the L2 and R2 hydraulic systems here. We need to come down here and disconnect this, open the guarded switch over here. This guarded, we open from normal to cut off. You see L2 and R2 is the hydraulic system it uses. It's a stabilizer, so you use alternate pitch ring stabilizer and use only the normal afterwards. Over here you can use only manual trimming for the horizontal tail. So you just saw how to use the trim. I will show you also in flight. So now I will show you the side stick, how to use all the other flight controls for controlling the aircraft in flight, having direction control, stability, and also change the attitude of the aircraft as it flies. So maybe you can see here. You can see here we have the side stick, Lszh Extreme 3D. Maybe better view like this, so you can climb the aircraft. Hope you have a better view right now because I'm trying to fix the view. You can climb and you can descend, you can make turns right and make turns. So you can use only the control wheel if you wish without using the tail. Use all the ailerons and spoilers, make turns left and right. You can use only the vertical if you like. You can use only the rudder pedals. So all these are interconnected, they move together. You can use coordinated flight. You will have to move all the surfaces together. So you can see the side stick deflection over here. The side stick deflection of the flight controls is proportional to the yoke deflection. You can see like in the Airbus aircraft. We have also the flight controls here. So you You can see the captain and the first officer are interconnected and move together in flight unless we have a failure, not like in the Airbus, which we have priority of one side. So now we move all the thrust levers here. See also the thrust levers moving forward and aft. So you can use together flight controls and thrust levers in flight like this. We have also the tiller nose wheel steering. We have nose wheel steering in the rudder pedals also, and the vertical rudder. So I will show you the outside view now. Also this nicer view over here. So you can see also this way I'm controlling the flight controls of the aircraft. Climb, descent, make turns left and right. Maybe so make turns left, right, climb, descend using the elevator, ailerons and spoilers left and right, and the rudder. Also the horizontal trim stabilizer and the thrust levers over here. So I will show you now the outside view of using the flight controls of the Boeing 787-900. So I'm gonna show you now. I'll do the exterior view again, and then make all the other systems demonstration. So you can see now you can use the tail for climb, descent. Let's see, this is the tail function, as you can see. So the rudder, the vertical tail. So we have the horizontal and vertical tail in the ailerons and the spoilers like this. To make turns in flight, all the flight controls. So now I will show you the rest of the systems inside the cockpit. I will continue now with the autopilot flight director system panel, the thrust levers, then we'll make an engine start demonstration before showing you the overhead. I will show you the overhead panel and how to start the engines, the process, and make a complete flight from takeoff, climb, cruise, descent, approach, and landing in the end part of the video. So stay with me until the end part of the video. So we'll continue now. So now we need here over here autopilot flight director system panel. We need to fix a few values. So you see the autopilot flight director system panel over here, the auto throttle left and auto throttle right, autopilot engage and disengage switch, LNAV, VNAV over here, auto throttle arm and disarm. Flight director cancels over here the modes. You can see the warnings also here change, so you cannot reactivate them unless you have the flight director on. Change the airspeed. We have other modes like you can see climb continues, VNAV, LNAV, which are interconnected, the LNAV and the VNAV from the flight management computer, XFAR, X transfer, indicated airspeed, VNAV, flight level change, auto throttle, climb continues, flight director and autopilot, engage and disengage. So this is the airspeed guide of the aircraft, the bang angle, and you can use auto or manual. The heading, we're gonna use the magnetic north pole heading of the runway, 136 degrees. The altitude here we're gonna change the altitude we're gonna fly. Altitude. We're gonna change it again. We have the VOR localizer, the approach for the autoland function over here, as you can see. And we have the vertical rate of climb and descent of the aircraft, and it's hundreds, thousands feet per minute over here. You can change also this value. You can see zeros, you can level of descent like this, and climb like this. The other way you will see the plus now. You can see also the hold value for LNAV and altitude, for the heading and the altitude, and for vertical speed function. So now this will affect over here the display. We have also the auto throttle disconnect switch here. You press this switch in the thrust levers, this auto throttle disconnect. We have the takeoff go round switch here. You can see takeoff go round, top gas switch, and auto throttle disconnect switch. And we have also, I will show you the thrust levers in a couple of minutes. I'll continue with the autopilot flight director system panel over here. I will show you the primary flight display, the indications. So we have the functions now. Well, the airspeed indicated, airspeed selected from the autopilot flight director system panel, 253 knots. Altitude to 1430 feet above the sea level, barometric altitude, radio altitude 2 feet. Target altitude 35,300 feet per minute. You can see this needle is moving up when we climb and down when we descend. You can see the barometric pressure 29.92 inches of mercury. The altitude indicator, artificial horizon, the pitch ladder indicates 2.5, 5, 7.5, 10 degrees, pitch up or pitch down. Bank angle also here. When we make turns, you can see the SSI here. The waypoints we have to climb through as we fly, then descend and cross through the purple lines. You will see the next waypoint we have to fly through. Over here, IDF left and IDF right, GPS. So this is the navigation system. As you see, the flight plan, horizontal over here, climb. We have to cross through some waypoints. So this is all the navigation system we use. The terrain, the airports around you can see the descender. You can see also the plan system here, the flight plan display. Maybe it shows more clear what we have to do. You can see the runway also here, all the waypoints and the aircraft where it's located right now besides the runway, the distance. So we have here also, you can see the runway we're gonna use here for takeoff, runway 14, the taxiway we are parked in front of it, the other runway. You can see the vertical also here. We are on the ground right now, but when we're gonna fly, you're gonna see we're gonna be above. We can see the terrain levels here around us, so we need to avoid the terrain and other aircraft. We're gonna see them displayed. So this is the navigation display and the primary flight display. So the pilot flight director system panel explanations are done. Need to continue with the, I believe, other systems, a couple more systems we need to speak about. We have the upper and lower ACAS and indication control system display that displays the engine's functions. You can see the N1, which is low speed starters, have low pressure compressor, and turbine of the 200% engine left and right, and 19.8% maximum takeoff limit with green 100.4, red, green, and yellow limits. Some messages, warnings with yellow. Exhaust gas temperature left and right. So this is the left engine versus right. exhaust gas temperature, and 2, which is the high speed starters have the high pressure compressor, and 2 band of the turbofan tube, which is ending. This low speed starters have low pressure compressor, 2 band of the turbofan tube, which is ending. Fuel flow per inch per 1000 kilograms or 1000 pounds, oil pressure, oil temperature, oil quantity, and the vibration of the entry stage of the engine. You see also flaps, stabilizer trim, rudder trim, landing gear up and down. Now it's down, extended. When you move the landing gear, parking brake set, doors. Also you can see landing gear over here, normal, alternate gear. We have a failure, auto brake, reject to takeoff. Over here you can see the weight of the aircraft for takeoff. Total fuel on board 33,600. Saturated air temperature and the fuel temperature right now. So we're gonna have a few more things to see. We have this. We can retract the flaps and extend them again. You will see the flaps position here, and you can see the flaps are extended fully right now. So this is the flaps. The speed brakes also here. This extends the speed brakes, as you see. So this is this lever. We have also the fuel flow to the left and the right engine, fuel control, cut-off switch, the stabilizer I told you already, the fire extinguishers, left and right engine, pull-out switch, so also the fuel flow, the transporter, the radar trim. So this is the radio and communication panel. Then we have the overhead panel. I will show you, for instance, the primary flight control computers that should be in the auto position, as I told you. We have the heading, the air data computer here, heading reference and inertial reference system, GPS receivers, laser gyroscopes, gyroscopic precession and deceleration of the aircraft. Over here, air data, pitot static, pitot dynamic, pitot tubes. So airspeed, altitude, and altitude difference as we climb and descend, and airspeed distance is all the air data. You see them displayed is from this displays over there. Also has the GPS receiver and magnetic compass or geographic North Pole. Other data, angle of attack of the aircraft as it flies, angle of attack sensors, radio altitude, so versus barometric altitude, barometric pressure. So this is all the air data over here located, flight control surfaces, other systems. Also the overhead panel now in a couple of in 1 minute. So I will show you first thrust reverse here, the engines. We move the engines up and you'll see the reversers are engaged, are open. Reverse thrust. So this is reverse thrust. You can see it open, we can close. So this is how to engage the reverse thrust, like this, and disengage it later. So we have over here the overhead panel. I will start showing you. I think we did all the systems right now. We have also the mouse pad over here. This is the mouse. I use hand finger to move around the screens over here. The digital displays sensor. So we have the electrical. Also now how make an engine start demonstration. I'm gonna start the APU. We need the APU to provide electric and pressurized air, electric power pressurizer. So I will talk you first about the engine. We have the GMX engine installed in our Boeing 787-900 aircraft. One the left wing, one the right wing, for symmetrical thruster and redundancy. It's one contains a gearbox with the FAREX. So I will show you also that the pressurizer. I forgot to mention pressurization. Turn to the manual over here. You will see display over here. Camping altitude, rate of climb descent, differential pressure, landing altitude, and the airflow valves in the open and closed position. So this is the cabin pressurization. So we have the engines, the NX engines, turbofan towards engines. The producer lab thrust is one contains a gearbox with the FADEX. The FADEX are the full authority digital electronic control computers, one installed per engine gearbox, dual channel redundancy controls, monitors and displays all the data you see from the engines, like the N1, which is low speed status of the low pressure compressor turbine of the turbofan towards the engine, in the upper and lower ACAS, all the multifunction display. The exhaust gas temperature per engine, the N2, which is high speed status after high pressure compressor turbine of the turbofan, which is ending the fuel flow per inch per 1000 kilograms or 1000 pounds, oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. The FADEX also control the pressure inside the engine, the outflow valves of the 5th and 9th stage, which supplies other systems. Also the pressure regulators, if we have a low pressure or other pressure, they can open and close the outflow valves in the higher or lower position to increase or decrease the pressure inside the engine. So the outflow valves and the bleeder from the bypass stage of the fan supply other systems like the hydraulic fluid pressurization tanks, all the flight controls movement you see here, like in the wings, the rudder, the elevator, as I show you. Moving together, ailerons and spoilers, all these need hydraulics to function, all the flight controls here. So this needs hydraulic power for the control surfaces. To move, we have hydraulic power for the thrust reversers of the engine, for the landing gear extender retract, parking brakes, and also normal braking, nozzle steering, and other functions, flaps and slats extender retract, horizontal trim stabilizer, speed brakes. So all these use hydraulic power, which is supplied with pressurizer from the engines. Also we need pressurizer for air conditioning, ventilation, and cabin pressurization system, and for wing and engine anti-ice. Also we need either from the engine or the APU, which is a small auxiliary power unit in the tail of the aircraft we use mainly for starting the engines in the ground. So we're gonna start the engine using the APU. It's gonna supply us with alternate current and also with pressurizer to supply the engine starter. Also we have so a few more things about the FADEX control, the engine start, engine shutdown, engine failure, fuel flow to the engine, fuel metering unit, oil heat exchange sensors. We need to heat the fuel all the time using the recirculation to the engines from the tanks, so it won't freeze in flight, and this will duct heat from the engines, and also supply with heat the fuel or the oil system. And also we need this is controlled by the FADEX. Also we have as I told you, our pressure as well as we climb or descend into higher or lower altitude. So as we take off, let's say from the sea level, and climb higher like 20,000, 30,000, 40,000 feet above the sea level, like 9,000, 10,000, 11,000, 12,000 meters above the sea level. As we climb higher, the airspeed, the air temperature, the oxygen level, the pressure of the atmosphere, and the air density, and so they become like less than that of less than half than that of the sea level. Also the temperature of the air becomes freezing, like -30, -40, -50, -60 degrees below zero in Celsius. Also the aircraft will gonna fly with an airspeed rate like 2 or 3 times faster than that of the sea level, so it's gonna have a higher intake of air from the front fan stage inside the engine for burning and for compression. So we're gonna have a difference of fuel mixture every second as we fly from takeoff, climb, cruise, descent, approach, and landing. As we descend, and vice versa. So this control the fuel mixture every second using the FADEX automatically instead of doing manually like in the turboprop piston smaller aircraft. So it's a good thing to have the FADEX installed into your aircraft. Now I'll show you the overhead panel and show you also the displays that display the digital format of all the functions of the aircraft. So we have here the APU. You can see the electrical, the battery, APU generator, left and right IDG, the great right generator, contactors, 120 to 200 volts, 400 Hz frequency. So we start the APU and external power in the ground. Primary flight control computers, I told you, in the auto position here. Air data computer here. Flight control surfaces, some other systems. At the door power, passenger oxygen, window heat, rammer turbine over here. For the hydraulic fluid pressurization, we have a failure of the engine, so we turn off the hydraulic here system. You will see the primary and the demand, the left and the right engine over here. So we turn back on and to the auto. So we have also the lighting system and the windshield wipers. We have the fuel, we have wing and engine at the eyes over here on or auto position. We have the fuel system over here. We have the electronic, we have the cargo fire and APU fire, some other systems here. The engines, the electronic engine control for the engine, normal and alternate. The auto start for the engines. I'm gonna show you in a couple of seconds. Fuel jetson, you can dump some fuel inside to lose weight. To make an emergency landing, select how much fuel to remain. If you're overweight for landing. So we have the fuel system, left and the right wing fuel tank, the center tank, the balance, the crossfeed. So fuel booster pumps, the balance and the crossfeed on. The crossfeed can feed either engine with other tank or either pump. We have a failure, so we turn back on all the fuel booster pumps and off the balance and the crossfeed. We don't need that. So we have here the cabin pressurization, the pressurizer manual. We need to use the outflow valves, climb, descend, open, close, and select landing altitude. So we use the auto, and this is the pressurizer from the left and the right engine, from the APU, and the air conditioning ventilation system also. So I'm gonna show you now last things, the displays of the digital format. What you see in the overhead panel right now is also displayed. All the diagrams here are displayed in digital format, so you can follow the systems in a better way. So we see the systems here, the status. You can see here the hydraulic 5000 psi, quantity APUs running, rotations per minute, oxygen and liquid cooling. The electric, you can see the left and right IDG great drive generator, the APUs running, the main battery voltage, the generators contactors are connected, supply main battery and APU battery volts and number. So you can see the hydraulics, where the hydraulics systems fluid goes, which systems use hydraulic system and they're working. You can see primary demand, the left and right engine, C1 and C2 the electric driving, 5000 psi, 5100 left and right and center, and the quantity of hydraulic fluid. The fuel on board, you can see the left and right wing engine, also, and the left and right wing tank, center tank, how much fuel you have in each one, 11,000, 11,000 and 13,000, 35,700 total. The low and high pressure fuel valves in left and right engine are open and feed either left and right engine. Also the crossfeeds are off, but if we turn them on, we can feed either engine with either pump or either tank, or also balance the fuel. The APU is fed from the left wing using the DC motor. You can see the fuel booster pumps forward and aft. And also you can see here the minimum fuel temperature, below which the fuel will freeze, minus 37 degrees, and the fuel temperature right now plus 1 degree. So we need to heat the fuel from the engine's recirculation system, so it won't freeze. Likewise, like the oil, which is done also automatically. The air system, the cockpit and the cabin, the pressure from the engines and the APU. The doors are closed, the cabin can be pressurized, the gear. You can see the temperature of the brakes here, and the pressure of the tires and the nose wheel, also flight controls. maybe last system to see. So you see the flight controls over here. Alright, everything is working normally. Rudder pedals, level steering. So this is how the display of flight controls, as you can see. Normal. You can just see the tail, climb descent, vertical tail, rudder pedals, and the stabilizer trim. You can see also the engines and the wings. F is display maintenance, circuit breakers if we have a failure, reset digitally with digital system. So we have only one system left. The checklist over here. So we have checklists like Boeing 777. Check everything is normal before taxi, before takeoff, approach and landing. So we go back in the navigation display. We need to turn off the engines now, make an edge start demonstration here. So you're gonna see engine start demonstration. Turn off for both engines, left and right. So you'll see all the systems here reset. If we turn off both engines, you'll see the warnings with the yellow color. It's amber and the engines are going, slowing down. So you can hear the roll on the engines. We need to use the auto start now to the on position. Over here, both engines auto start very quickly. You can see the yellow reset. So we're gonna have the fuel flow in a couple of seconds. Now we have the pressurizer being admitted from the APU into the engine. With the N2 only increases. You can see above 20% we can start the fuel flow right now. So we have pressurizer. You can let the fuel flow like this. You will see the auto start. Auto start is kicking in. So you'll see as the pressure increases above, let's say 50%, the system will start coming to life again. You see the warnings start disappearing, and almost 60% we're gonna have the running engines here. So both engines running. We can go for takeoff. So stay with me now. You're gonna see the complete flight from takeoff, climb, cruise, descent, approach, and landing. Thomas Hatsios with them on a couple of the Boeing 787. Tonight's flight. So now we take the clearance from the air traffic control. Disarm the parking brakes, advance the thrust levers. Also flap set higher for takeoff. So advance the thrust levers like this. So we need to align with the runway like this. So we advance the thrust levers forward. You will see. And advance full takeoff power after it's stabilized. So we have 100 knots. Align with the rudder pedals, V1, pitch trim a little bit slightly. And we take off. We have the normal takeoff, landing gear up is a positive rate of climb. So you can see, keep climbing, maximum takeoff power. You can see here all the data. You can see the pitch altitude like almost 17 degrees. Now we decrease, so we have the airspeed 170 knots, the stall speed over here we need to avoid during the whole flight, the altitude above the ground level, and the vertical rate of climb, the pitch ladder. So you have the flight plan here, horizontal and vertical, how far away we are above the ground. We need to start turning in a couple of minutes. So we can see also a little bit further off the display. The terrain you can see with red, yellow and green variation, and the flight plan here. So we can see also the outside view as we climb away from the airport. The Zurich here, the view, beautiful view, and the Switzerland. So we go now for the turn over here. So now we start turn. I should have started earlier, but it's okay, no problem. And we have 16 more minutes. For this flight to complete. So maybe flaps up. We have also accelerate a little bit faster. So we need to pitch down a bit, maybe. Use a little bit less pitch string and increase the airspeed. So maybe less flaps. And we have also increased our airspeed component as we fly. So now we fly very close to the stall speed margin. We need to level off a bit. But we're gonna fly very fast also. So we need to avoid this yellow and red limit. Pitch down the aircraft a little bit to increase the airspeed, as you can see. And then we're gonna make a turn here. Gonna initiate the turn. So this is also the view here from around the Switzerland as we fly the Boeing 787. So this is very nice view here. You can see also the Germany, the France this way, the lakes. So we're gonna make a turn now over here, coming into the flight plan. We're gonna make a more turn, and we have 15 more minutes for the video to complete. 21,000 feet. So you can see here once again, nicer view from outside. The galaxy also. And I'm gonna see the lakes now. And the pitch down a little bit again. It's up too much. Because we're flying with a higher airspeed now. With a higher thrust setting actually. It pitches up more. So this is the flight line we have to fly through, and we'll fly a little bit higher now. And we have 11 more minutes to fly, 35,200, and this beautiful view, another aircraft crosses through over here, the sky. And I believe we have the chemtrails now, very beautiful view of the chemtrails and the contrails over here. The galactic view of the Boeing 787. We have also the Germany, the Bayern Munich in front of us, and the France. We have the Germany, my homeland, and the Swiss Alps here. So we need to take the turn, I believe, now for going back home, because we have about maybe 10 more minutes left. So we're gonna be flying a little bit more like this, and we need to make a turn, as you can see. So this is gonna make a turn now, because we have like 10 more minutes left for this flight. So it's better if we go faster. We're gonna make a shortcut here and come back up for landing. 37,000. Also decrease the thrust from the engines a little bit. Hope you like the chemtrails, the lake, beautiful lake over here, Switzerland, Germany, this side, and the France. Also we have the Switzerland and the Italy in this side. Gonna have the view of the galaxy in a while as we make the turn. As you can see here, so make a little bit sharper turn, coordinated. And we have about 9 more minutes to go back into the airport. Hope you like this turn over here. So we need to align with the flight plan here now. You can also connect, I believe, the autopilot or nav, the nav. The autopilot connect now. You can steer the aircraft using the autopilot, as you can see. So a little bit more nicer view here as we fly the galaxy, the galactic view of the Boeing 787, the lake view also here, and we turn back to the airport, as you can see, and the flight plan. So we turn back for the flight line over here, and we have 7 more minutes left. For this flight, we need to descend. Start descending and fly through the waypoints here. As you can see, so we are descending to the airport right now. I'm gonna use idle thrust. Both manual. We disconnected one auto throttle, and you see we had only one engine in the manual mode, using one auto throttle. So we need to approach full landing. We have 6 more minutes. Descending is also this for the descent. So we need to decrease the altitude one more time. And we have 5 more minutes, I believe, for this flight to complete. So we're gonna make some shortcuts in the flight plan. As we are descending, we'll override some waypoints. So we need 5 more minutes for approach and landing. Keep flying manually here, as you can see. That's a nicer view here. Need to be a little bit lower, and we have a few more minutes left. I'm gonna start turning to the airport. Four more minutes. So we start the turn now over here. So we turn manually while descending. We use some flaps also and some more airspeed. So we have the airport now located over here, and we have 3 more minutes to go into the airport. We need to make a turn to the right, increase the airspeed. So it's gonna be our view for landing over here as we are approaching. And we have 2 more minutes left actually. So gonna be aligned with the Lszh localizer. Have also some clouds as you can see. So gonna be aligned with an Lszh localizer. Leveling off a little bit here. So we are almost aligned. Very good. And we need about a minute to land. We cross a cloud right now. Very good perception. You can see the Lszh localizer on the indications here as we fly. So we have 1 more minute before the video ends. We need to add some airspeed. For the landing to reach the landing point. So we're almost here, aligned with the runway, use flight controls for alignment, and also we are very close. We have some side wind, we need to align with the side wind, some flare over here, so flare, you can see the flare, landing, touchdown, beautiful touchdown, parking brakes here, align with the rudder, and thrust reverse, idle thrust and thrust reverse, and speed brakes, it lowers down. So we're slowing down on the runway and we are very aligned, as you can see, very beautiful landing. Now we're slowing down, keep slowing, we have a few more seconds before the video will end. So you can see the landing gear, all the systems